So it was discovered that when you shine light or electromagnetic radiation onto a piece of metal, it will allow electrons, given the right circumstances, it will allow electrons to be emitted from that piece of metal. So this light is absorbed by the metal, and electrons are emitted. Now that in itself wasn't too surprising. See, this is the specifics of this discovery is one of the core bits of evidence for quantum physics. So the reason that the main observations, I'm going to type down the main observations now that was noted during this experiment, and then we'll look at what that meant. Okay. Just in summary, then, if the frequency of the light was below a certain frequency or certain value, which is we call the threshold frequency, no electrons were emitted. Let's just have a look at the diagram. Whoops. Let's have a look at the diagram again. Okay, try to get them both on the same screen at the same time. No matter how high the intensity, so you can increase the brightness of the light. It won't make any difference as long as you don't, as long as it's below this threshold frequency. That was one observation. The second observation was once you go above that threshold frequency, if you then increase the intensity, more electrons were emitted. But if we looked at all the different kinetic energies of these electrons, the highest kinetic energy, the maximum kinetic energy, that stayed the same. Also, if you go above this threshold frequency, once you increase the frequency, so in the first case, we're increasing the intensity, and that caused the more electrons. In this case here, we are increasing the frequency, and this changed the maximum kinetic energy. But the number of electrons stayed the same. Okay, so the intensity changed the number of electrons, but the frequency changed the kinetic energy of each individual electrons. And if you didn't give it enough, if the frequency wasn't high enough, you wouldn't get any electrons emitted anyway. Okay. So basically, the reason for this observation here is that the frequency is related to the energy. Sorry, is related to the frequency. Okay. So I think that. Okay, I'm not sure about that other equation, so we're going to leave it. We're going to go over the top. E equals hf. Okay. And so we can work out the energy of a photon. So we're now thinking of the idea of light not being a wave, but being individual particles. And each particle of light, known as a photon, has a certain amount of energy, which can be worked out by the Planck's constant multiplied by the frequency of what we considered before to be the wave. So, and the idea is that the electrons can only absorb either one photon or no photons. You can't absorb a little bit of that photon, a little bit of that photon. Or you can't absorb two photons and then eventually have enough to be able to escape the metal. That's not how it works. And that was the discovery that they made. And so they realized that each electron can absorb a certain amount of light. And if it was enough, if it was above this frequency here, if it was above the threshold frequency, then it would be liberated from that from the metal. The amount of energy needed to be liberated from the metal is called the work function, and so that is drawn like this. So that means that when I give it some energy. So if I give it a certain amount of energy, which can be worked out by hf, that's going to be first used to liberate the electron, which is the work function. And if I have anything left over, then that's going to be converted into kinetic energy. Okay. So once I've So this explains now the third third observation. Once you've given it enough to escape the metal, so more energy than its threshold frequency, more energy than the work function, then any leftover energy will be turned into kinetic energy. And so the more leftover energy, the more kinetic energy. Now, the intensity is actually, now we've got this idea of photons instead of waves. The intensity is really a measure of how many photons. And so if we have a high intensity, we're blasting it with lots of photons. That's the difference now. Beforehand, we would consider it to be like large waves, large electromagnetic waves. Now we're thinking about it as number of photons. Okay. And so because we've got more photons with a higher intensity, then more electrons can be liberated. We'll have a higher ability to be able to do that. Okay, we've got more. But if I don't give them enough energy, if I don't give any of these photons enough energy, in other words, lower than their threshold frequency, then none of them, doesn't matter how many photons I shine onto the metal, none of them will be emitted. None of the electrons will be liberated. And if I go above that work function, so above the threshold frequency, then all the photons are able to liberate electrons, and so therefore, and each one has the potential to liberate one electron. So we're going to have more free electrons. However, each electron will still have no more kinetic energy than they would do at a lower intensity. Okay? Does that kind of make sense? So what you want to try to do now then is, in your own word, think about how would you word the conclusion based on my explanation I've just given.